We're going to give this a shot. So first of all, I wanted to hashtag this segment as hashtag we got this. This is going to be notes for your 10.1 section, beginning with this question. So an hour hand of a clock moves from 5 to 9. Through how many degrees does it move? So we've got 1, 2, 3, 4. 4 out of 12 sections, which reduces or simplifies to 1/3. So then we have to think about a full circle has 360 degrees. So the hour hand is only moving 1/3 of 360 degrees. So we have 1/3 times 360, and we end up with it moves 120 degrees. Another way of thinking of this is proportions. So we have 4 out of 12, and we want to know how many degrees out of 360. And then you can solve it the same way, and you would still come up with x is 120 degrees. Alright, moving on, talking about reading angles on a protractor. Several ways to name an angle. First of all is, if I look at this yellow protractor, I have angle A, B, C, or I could say angle C, B, A, or since there is only one angle here, one vertex coming from there, it could be called angle B because there would be no confusion of what angle I was talking about. So when you read on a protractor, we would read from the beginning line that starts at the 0. So this way, on this two-sided protractor, the 0 starts here and goes up. So then this angle right here, angle ABC, would be 50 degrees. Down on the green protractor, it only has one side of numbers, but you will see questions that ask you about angles, such as if I were to ask you for angle HAG. So we would not say that it's 160 degrees. We would have to think, how many degrees did that actually move? So it's at 180 to 170 to 160, so that would be 20 degrees. Okay, so we read it that way. I could not call this angle A because we don't know which vertex or which angle it was going from, because I could name angle HAB, and that would be HAB. And so we would be looking for that angle, which would be 180 because that's a straight line, but I would go ahead and just subtract that 20, and that would get me back to 160. So be very careful on how you read the protractor on the My Math Lab questions. Complementary and supplementary angles. Complementary angles are going to be two angles that are going to equal 90 degrees, and supplementary angles are going to be two angles that equal 180 degrees. So the sum of whatever they give you has to be either 90 or 180, depending on supplementary or complementary. Something to remember in this same set of things is that if they tell me I have a right angle, that could be made up of two angles like this, so those would be complementary. We would have angle 1 and angle 2. those would be the measure of angle 1 plus the measure of angle 2 would have to be 90 degrees, so therefore they're complementary. Something I want you to remember is that a straight line forms 180 degrees, so they could give me something like this, and that would mean angle 1 and angle 2. Here, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So just some things to remember as you start writing your equations or doing some simple math with degree measurements. Alright, so this question is what you're going to kind of see in my math lab. It says find the complement and the supplement of an 82 degree angle. So the complement would mean that some angle plus 82 would have to be 90 degrees. Well, let's do it this way. Let's match up my colors here. So some angle plus 82 would have to be 90 degrees. Or over here with the supplement, some angle plus 82 would have to be 180 degrees. So I'm setting it up as an equation because the other part of tonight's lesson, or Monday's night's lesson, would have been practice on solving equations. So I kind of want to try to hit two things with one stone here. Same thing, solving equations. We would subtract that 82 degrees that they gave me, and x would be 8 degrees. So the complementary angles would be 82 degrees and 8 degrees. Over here, same steps. I moved that 82 over, subtracted from both sides, and here the supplement would be 98 degrees. So 82 and 98 are supplementary angles. Alright, so the next type of problem, the measure of an angle is 34 degrees greater than its complement. So an easy way to picture this is we have that right angle. Because we know they have to be 90 degrees, so we can make a picture like this. So we have two angles. We have one angle that we don't know, and then the other angle is 34 degrees greater. So that would be that angle we don't know plus 34. So that angle measurement is x plus 34. These two guys together must equal 90 degrees. So I have x plus 34 equals that 90 degrees. Let's work through our equations. We combine like terms. So 2x plus 34 equals 90 degrees. Subtract 34, from both sides. So then I have 2x equals 56. And then if I divide by 2 on both sides, x equals 28. So before you make sure you read what it's asking you. So this angle right here is 28 degrees, but this one is 28 plus 34, which would be 62. And then we can just double check. 62 plus 28 does equal our 90 degrees. Alright, moving along to different types of angles that you're going to see in this next part of the lesson. Vertical angles. So on vertical angles, we have two lines that intersect, 4 angles happen. We have angle 1, angle 2, angle 3, and angle 4. Vertical angles are opposite of each other, sharing the vertex. So angle 2 and angle 4 are vertical angles. Angle 1 and angle 3 are vertical angles. what you need to remember about vertical angles is that they are congruent, which means they have the same measurement. So if I were to tell you that angle 3 was 68 degrees, you should be able to automatically match that up with angle 1 being 68 degrees. And if we stay true to our complementary and supplementary, and we know that all the way from here to the other side forms 180 degrees, I would just need to say 180 minus 68 is going to give me my other degree, which would be 112. So 4 is 112, which matches up to 2, which we know is a vertical angle, so it also has to be 112. Alright, on this next example we have same scenario, two intersecting lines. I have the same 4 angles that happen, but this time I'm telling you x, which is angle 4, so we'll just go ahead and make this be x. X equals 70 degrees. So right away you should be able to say, well, this angle matches up to this angle, so that means measure of angle 2 is also 70 degrees. And then in true fashion from here to here, remember is a total of 180 degrees. If I already have 70 there, I would just say 180 minus 70. That gives me 110. So the measure of angle 1 is 110, which means automatically vertical angle number 3 measures 110. So the measure of angle 1 was 110 degrees. Its vertical angle 3 is also 110 degrees. Here's just a picture of different angles that we're going to talk about. Alternate interior angles, and really these are happening because we have, let me move, we have 2 parallel lines cut by a transversal. So these lines are parallel, cut by a transversal, which gives us the following 8 angles that you see in those other pictures. 1, 2, 3, 4, 5, 6, 7, and 8. So 8 angles happen because we've cut something by a cut the parallel lines of the transversal. So automatically, just going back to and reviewing our vertical angles, you should be able to list vertical angles. So if we list our vertical, we would have a possibility, I'll just list a couple. Angle 1 matches up with angle 3. Angle 5 matches up with angle 8. And there's several others there that you could find. But let's focus on the new type of angles. We have alternate interior angles. So something to think about. Inside these parallel lines is what we're calling the interior. Okay? So all of these guys are interior angles. So alternate interior, alternate tells you it alternates over the transversal. So angle 3 and angle 6 you can see in the picture are alternate interiors, but also 4 and 5 would be. The same thing is like vertical angles. These angles are congruent to each other. So if I were to tell you in this little picture that 3 was 40 degrees, you should be able to say 6 is 40 degrees. Okay? Alternate exterior. So if these guys, 3, 4, 5, and 6 are interior angles, then these 4 out here are what we call our exterior angles because they're not inside of our parallel lines. So alternate exterior angles, they alternate again over the transversal, so like 2 and 8, or 1 and 7. If we're looking at my picture, if you're looking at their picture, they have 1 and 8, and then 2 and 7. So make sure they alternate on different sides of the transversal, and they're both on the exterior. And those are also the same degree measurement. So again, if I told you that this was 110 degrees, then 8 is 110 degrees. Corresponding angles, that means 1 in, 1 out. So 1 in, 1 out. They're on the same side of the transversal. They're also congruent. So you have several sets there. You can see all of the pairs that match up in this side right here. So not only the ones that they have highlighted in the picture, but also the other pair along with it. So let me make up an example for us. So here's our parallel lines cut by a transversal. And I'm going to pretend that this is a 50-degree angle right here. That's the only one that I've given you. When they give you at least one angle, you should be able to use all of those other angles from the chart, what you know about them, and what you know about supplementary angles that form a line to get all the rest of those angles. So we had a total of 8 angles, and now we're going to find the rest of them. So I'm going to number these guys off. And then we're going to talk about this. So the way I would look at this is I would say, okay, 50 degrees is from here to here. Its vertical angle is number 3. So I know vertical angles are congruent, so the measure of angle 3 would have to be 50 degrees. And then I would remember that if 3 is an interior angle, I alternate on over the transversal and stay interior. That would mean that 5 is also 50 degrees because alternate interior angles are the same. Keep going on that. The vertical angle to 5 would be angle 7. So I would say the measure of angle 7 is also 50 degrees because of its vertical angle to 5. Now, if you also look at this, you could see that 7 and 3 are also corresponding angles. One is out, that one is out, this one is in, and they're on the same side of the transversal. So that's another way to prove to myself I was right, that it is 50 degrees. So how do we find the other ones? Well, I'm going to go back up to the top, and I'm going to say, well, I know right away that from here to here, I have to have a total of 180 degrees. I already have 50 there, so that means that I'm left with 130 for number 2. So the measure of angle 2 is 130 degrees. If 2 is 130, then the vertical angle of 4 has to be also 130. So now the measure of angle 4 is 130 degrees. I'm going to go a different route. So a corresponding angle to 4 would be 8. So corresponding angles are congruent, so 8 is also 130 degrees. Vertical angle to 8 is 6. That makes it 130 degrees. And that gets us all 8 angles. So good luck. Remember to ask